Hi, welcome back to Canadian Competitive Math. We are on day 9 of our journey for this math exam, and today we are going to solve a question about geometry and parabola. So what do we have here? All the vertices of triangle ABC lie on the parabola defined by y equal to x square, with A at the origin and BC parallel to x-axis. The area of the triangle is 64 units. What is the length of BC? So I'll give you 5 minutes. Try to solve this question on your own. We'll come back and you can check the solution with my solution I'm developing here. Hope you have solved this question by yourselves, and I'm going step by step into my solution. To start, I will make a figure for this problem here. We have parabola y equal to x square, and there's a triangle ABC with A at the origin, and we also noted that BC is parallel to x-axis. So what are the principles we need to know? Principle 1, y equal to x square is symmetric about y-axis. So you can look at the shape of this curve. This is symmetric about y-axis. Principle 2, since BC is parallel to x-axis and B and C are on the parabola y equal to x square, B and C are symmetric about y-axis. Meaning, if I take an image of C about axis y, we will get point B. Meaning, B and C will have same y coordinate, but they'll have same x coordinate with opposite signs. I will discuss this a little bit more later. And principle 3, we know that area of the triangle is half times base times height. This is like a common area of the triangle obtaining method. As I was telling before, since BC is parallel to x-axis, y coordinates of B and C will be the same. We assume that y coordinate is y. Since we don't know the x coordinate of B, let us say that it's bx, and the y coordinate we already assumed it is y. Since this B is on y equal to x square, from that we can derive that y equal to bx square, meaning bx is minus square root of y. Same thing with coordinates of C2. We have cx comma y. So since y equal to x square, we have y equal to cx square. So then cx becomes square root of y. So since BC is parallel to x-axis and y coordinate of B and C are the same, we can obtain the length of BC as 2 times square root of y. Now we know the base of this triangle BC. You know the length of the base BC is 2 times square root of y. We also know that BC is parallel to x-axis. So to obtain the area of the triangle, we need height and base. We obtain base here. Base is 2 times root of y. So we need to obtain height. We already know that BC is parallel to x-axis. So the y coordinate of BC, either B or C, will be equal to the height of the triangle. We already assumed that y coordinate of B and C as y. So distance from A to BC, which is the height, we will know that as y. So from that, if you look at the area of the triangle will be half times BC times h. BC is the base, h is the height, and we substitute what we obtain here. This will be half times y times 2 square root of y. That will be equal to y to the power of 3 by 2, which we know that is equal to 64. So y is 64 to the power of 2 by 3. So we use all these power formulas, and from that we can say that y is 16. So we already know that BC, the length BC is 2 times square root of y. So it will be 2 times square root of 16, which will be equal to 8 units. So given all these constraints, they asked us to obtain length BC, and using the principles of coordinate geometry, we obtain length of BC as 8 units. Hope you enjoy this content, and if you want more content like this, and if you like my content, please subscribe to my channel. Thank you.